Let's begin with page 76. So in chapter 9, we have a very important theorem called the parallel access theorem. It looks like this. It is Ix is equal to Ix prime plus d squared times 8. It looks like this. And so let's look at what does it mean. Ix prime is the moment of inertia with respect to here. For example, on the shape on the right, x prime is here. So Ix prime is the moment of inertia with respect to centroidal axis. Sorry, let me put it on the left. So for Ix prime, this one, that is the moment of inertia with respect to centroidal axis. This one. What does it mean by centroidal axis? It means it goes through C, it goes through centroid. Okay? So for Ix, for any axis X, that it is equal to Ix prime plus d squared times 8, and Ix prime is with respect to centroidal axis. And for D, for value D, and the value D is distance between centroidal axis and I would say x double prime axis. Okay, and please put double prime here. Okay, we want to determine the moment of inertia for any x-axis. So it is equal to the moment of inertia of centroidal axis, this one, plus d squared times 8. We want to determine the moment of inertia, say here, for any axis, okay? Like x double prime on the here. It may be here or it may be here for any axis. For this x double prime. You don't need to do integration again. You can use the parallel axis theorem. That's these axes are parallel. What is parallel in Chinese? 平行哈，平行走。So for x double prime, for any axis x double prime, so it is equal to Ix prime plus d squared times 8. So d is the distance between centroidal axis and the axis you are looking for, the axis you are calculating. Is that okay? Now, it is a bit difficult to understand, so we work on an example after you write this down. Now let's move on slowly. And, so let's move on to our example. Moment of inertia of a rectangle with respect to axis xb. So where is xb? Xb is here, okay? And of course, we can determine this moment of inertia by integration. So we have I xb is equal to what times dA. So for reference axis xb, so what do we need to fill here? If we write x here, we should write x or y. Y, okay? Good. Y b squared dA. Okay? Because the distance between this slice or this stripe here from xb is yb. Does it look or does it sound logical? Right? So IXB is equal to integration of YB squared dA. So YB is this one. It's okay. So on this line YB is equal to 0, and on this line YB is equal to H. Because this one is XB, because this one is X, so this one should be Y. Always remember this. If we have X, Ix, that in the integral we have X, we have Y. It's okay. Now, so and for the integration, so let's work on it. So it is YB squared times what's dA? dA is equal to the width of the rectangle B times dyb, right? Because this this thickness is dyb. Now we put our limits of integration. So this is yb is equal to 0, and this one is the upper edge is yb is equal to h. Therefore we have integration constant 0 to h. Which is equal to, can you work it out? So yb squared to cube to the over 3 times b 0 to h, which leads to bh cubed over 3. Easy, right?